Okay. In the last class, do you remember I have taught you about the Johnson rules extension? So this was the example that I had worked out and you got the optimal sequence 3 one of the optimal sequence you got 32514, isn't it? Another two sequences you got it through 3 2, let me write down. Other sequences that you got, other sequences are 3 2 4.
Excuse me, ma'am.
Yes, tell me.
Ma'am, we worked out a different problem.
Okay, okay, let it be. Maybe I would have done some different problem, but I think you can work out this problem.
Yes, ma'am.
So it will be it's a
Ma'am, can
case
you please
study.
give us some minutes to write down the
Yeah,
information
yeah,
over there?
sure, sure. Write down. Okay. So this is one of the examples. So it's a case study. Okay. So that you can understand which is the optimal sequence. You can determine when you are getting more than one options. Okay. Note down the problem. I'm giving you time. Shall I start now?
Yes, ma'am.
Okay. See, this is the problem. You can see that these are the three machines given to you. The timing of the three machines given to you. You know that you can apply Johnson's rule if minimum of your this one is a minimum of this timing. That means minimum of this timing 6 is greater than equal to maximum of this one. Maximum here it is your 6 only, isn't it? So 6 is equal to 6. So you can apply Johnson rule. Is it clear to you all? Why, John? First of all, even if you are given the three machines, first of all, you should check the condition. Check the condition whether you can apply extension of Johnson wants to go for leave. So we used to fill up the forms like casual CL form, casual leave form. Okay, like for like that, there are so many. You might have heard the term work orders in your workshops also. Work order, like different forms are there in machines in industries also, like number one work orders. Okay, then your time cards, time cards, then inspection tickets, inspection tickets, then your tool and equipment tickets, tool and equipment tickets. I'll tell you one by one what does it mean by work orders. Let's say I've done one casting and I want that its property to be tested. Specifically, suppose tensile strength of that casting has to be done. What I will do, I will draw the dimension of that specimen. What is the size for that we follow ASTM standard for testing. So by as per ASTM standard, I will draw the dimension of the tensile specimen of my cast specimen, and I will give that work order, that is your work order. In that work order, my name, how many samples I have done, how many samples I want to be produced, and what is the time I need it, then what is the dimension of the specimen. Everything will be there in the work order, and I give it to the that shop. Suppose let's say it is a workshop, I'll give it to them. So this is a paperwork that used to be done and used to be followed. How many works they have done throughout a day or throughout a month, in month how many work order they have accomplished. So this is a work order kind of thing. So work orders are issued to the department to start the work. Similarly, time cards. Time cards means, that planning means your time is fixed. By this time, this part of the job has to be finished. So that each operation will be each operation that was the planned one, and what is the actual time taken by that machine and by that operator, that will be noted down in that time cards. This operation is being done and it took this much time, this much minute, whatever. So that is your time cards. Then that inspection is always essential. So this is the role of the inspection department. They will check whether the quality of work is being processed rightly or not, and whether the quality of the product or the part or the sub part that they are doing it is up to the mark or not. They will check that means it's a continuous process. Then tools and equipment tickets. So that this is the role of a tools department. They have to release so many tools for working. Sometimes one machine cannot work out properly, some spare part may worn out. Then it tools department will give that spare part to it, so that machining will not be hampered much. So these are all these are different forms that dispatching used to follow. So in this way, this concludes your first module, production planning and control. Now I will start your second module. So
Ma'am, you
second
won't
mod
be having any questions from this part, like dispatching.
come again.
Ma'am, won't we be having any questions from this part, the dispatching part?
Question means you
Like,
want numericals.
no, ma'am. Like, before we did those numericals, doesn't this like dispatching part play any role in that, like in
Dispatching
those
role
numericals?
plays an important role. Dispatching, see, that was planning. That means your Johnson's rule, materials requirement planning. That ever you are doing it. It is the actual production process. Okay, dispatching. Yeah, in dispatching, see, in Johnson's rule, you have you this work first, we will go to this machine, then we will go to other machine. In this way, this work will be done likewise. In dispatching, I've told you now like that. So you will see whether the work is being done accordingly. Then after that, you will check work is in progress. Then in between, your inspection department will come, and in between they will be checking whether as per the plan. So it's a process of checking whether the planned process as actual process is in line with your planned process or not. Okay, anything?
No, ma'am.
Okay. Okay, shall I move to the second module? Okay, so second module is your in. I think you have purchased the books and you have the syllabus, all of you. So second module is your inventory control. Fine. Inventory control. I think everybody knows what is inventory. Can anybody tell me what is inventory? Today there will just, I'll introduce it. In the next class I'll go to different inventory models. What is inventory? Please tell me. What do you mean by inventory?
Storage. Ma'am, inventory is not there, ma'am, in P-PAN itself, ma'am. In that book.
Okay, well, that we will discuss later on, in which book it is there or in which book not there. But first tell me, what do you mean by inventory?
Ma'am, it's like a list of things or whatever we have in stock.
In stock.
Yeah.
Yes, goods in stock. That is your inventory. So it may be the finished product, it may be the sub part, it may be some spares of the machines, it may be the packaging instrument, whatever that is essential for the product in future. That is your inventory. Fine. So you know that inventory, if you want to, you have to store the inventory. You need some place to put your inventory items, isn't it? So it kills your space, and you have to, if you don't have space, you have to take rent that room. So it will kill your cost. Okay, and if you're spending money, means ultimately your product will be costlier. So in this chapter you will know how to control the inventory. Okay, so before that I'll tell you, in definition point of view, inventory means, inventory is defined as the list of movable goods which are necessary which are necessary to manufacture a product, to manufacture a product and to maintain the and to maintain the equipments and machinery in good working condition. In good working condition. Okay, this is your inventory. Then again, inventory is divided into so many times, like your direct inventory and indirect inventory. Okay, direct inventory. Number two, indirect inventory. Okay, direct inventory, from the name itself, it indicates that it plays a direct role in the manufacture of the product, like raw materials, like you can say your raw materials, work in progress. And you know that every product is made up of so many sub parts, and some parts they used to manufacture, and some parts are being procured. So we can say that it is the direct inventory is your some purchased sub parts. So these are used directly, as these are called as direct inventory. Raw materials, your work in progress, your purchase sub parts, and finished good. Finally, your finished product, finished finished products. Okay. And now comes your indirect inventory. You know that for working you need so many tools. That tools you have to store it. And you know that machines, whatever you are using, maybe the lathe machine or the shaper machine, whatever you are using, they need some spare parts. When they won't work, they need some spare parts so that it can be replaced and it will be again in working condition. So It use so these may be termed under your miscellaneous items, consumables like, and again miscellaneous items and consumables like your brooms, cotton, etc. Isn't it? So like your spares, brooms, okay, and again gums, adhesives, oil, greases, candles, light, and some waxes, some letterheads, envelopes. All these things comes under your indirect inventory. Okay, like brushes, oils, lubricating oils, then your office supplies. Okay, so these are your indirect office supplies. So these are your indirect inventories. So again, there are so many different inventory costs. Shall I start now, or shall I stop in the next class? I will start deal with your inventory cost.
It's okay, ma'am. It's okay.
Okay. So then before that, we will go for the inventory control. These are the inventory. But I have told you that inventories should be controlled. So inventory. So this is your inventory control.
Ma'am, is movement inventories, buffer inventories, and anticipation inventories in the course, in the syllabus, ma'am?
See, uh, all inventories are there. So you can say it is in the course. Buffer stocks, everything, all are there. You have to work out the models, the cost associated with it. Fine.
Yes, ma'am. Yes.
It's a big chapter and it's a very important chapter. Okay.
Yes, ma'am. Yes.
Okay. Then inventory control. Okay. I've told you that inventories should be controlled. Inventory control means you make that it is that making the desired item of required quality and quantity available to various departments and whenever they need. That means it should not be more than always we cannot say, but we expect on the basis of our experience and on the basis of the past information we used to predict that this will be the inventory or the parts we will be needing in this coming year. So you should have such desired items, so you should have the desired items of required quantity as well as quality to the various departments and sections. You know that inventory, again there are so many different sections are there, you cannot mix it up all the things together. So in inventory also there are so many different departments, and various departments should keep the minimum qualitative things in their department. That is your inventory control. So what is the functions of inventory control? So first functions, inventory control function, let's say. Okay. First one, first out, first and for important thing is that smoothing out irregularities in supply, so that you should not have to wait. Suppose you need one sub part or you need one some spare part, some one machine is not working, so you should have in stock with that thing. Otherwise you have to wait, and if you're waiting means you're killing the cost, and ultimately there will be a loss, or the loss, or it will increase the cost of the product. So you should have the smoothing out irregularities in supply. So first one is your smoothing out irregularities irregularities in supply. It should not happen. Irregularity in supply should not happen. Then number two, minimizing the production cost. That is the ultimate of any production without compromising the quality, isn't it? Minimizing minimizing the production cost. Production cost. Number three, allowing organizations to cope with perishable materials. allowing organizations to cope with perishable materials. So other also small functions are there that you can go through that. These are the basic functions, and again, I've already told you that inventory also consumes your cost. So now I will start inventory cost. This is the most important thing. On the inventory cost, on that basis you will decide, using mathematical formulas and all, in which section you have to invest more, in which section you have to invest less. Like first of all, first invest cost is your first inventory cost is your, let's say it is your setup cost. Setup cost, I am using the symbol for as CS. Okay, because in the subsequent classes you have to work out the problems. So this symbol I will be using CS. Okay, first let me write down different cost. Second is your ordering cost. Ordering cost, I am using the symbol CO. This is your ordering cost. Okay, third is your purchase cost. Purchase cost, I am using the symbol capital P. Fine. Then fourth one is your carrying or holding cost. Carrying or holding holding cost, and I'm using the symbol CC. CC. Okay, capital CC. Next is your fifth one is your shortage. Shortage or stock out cost. Stock out cost. Okay. This symbol I'll tell you later on what symbol I'll be using it. Okay, so that you there won't be any confusion. So these are the different costs, and another cost is your revenue cost. Revenue cost. This we don't need for working out the problem, so I'm not giving any symbol to revenue cost. Why I'm telling you the symbols? Because if you follow different books, they have different symbols. So you will get confused. So better you follow one symbol. Okay, so that will be easy for you. Like in some books, shortage cost CS is also given to you, and setup cost I have already taken CS. So this one, I'll tell you in the next class what symbol I'll be choosing for shortage cost, because initially we will be working out the problems using your 1, 2, 3, 4 cost. In the later part of this chapter, I'll be working out using the shortage cost. Okay. So now we'll go one by one. Cost. What is the setup cost? First one, setup cost. So I think from the name itself, it is very clear. Setup cost, it is the cost associated with setting up of machineries, isn't it? Before starting the actual production process. Setting up means you have to, before going for actual production, you have to set all the machines, whether all the machines are running properly or not, all the machines have been properly lubricated or not, tools have been sharpened or not. All suppose in all these things you have to check. So that is your setup cost. You need little bit of maintenance for this setup cost. So it is usually independent of the quantity ordered for a product, isn't it? We cannot relate that this much for this much quantity, this is the setup cost. It is a generalized, all machines and setups are working properly or not. This is your setup cost. Fine. Next is your ordering cost. Ordering cost, this is your ordering cost, CO, ordering cost. So I think this is very clear. This is the cost associated with ordering of raw materials for production process. So it depends upon your the depends upon the quantity ordered for a product, isn't it? And ordering cost, not only it includes your raw materials, but also it includes your advertisements, your stationery, postage, because you won't order over phone, isn't it? It's not that, like that. You have to suppose you, it's a huge quantity, means you have to go for the tenders that how tenders are being published. These are tenders are published in your newspapers. So it is a cost of advertisement. You need some station, you have to go for the post and all these things, stationery, postage, telephone charges, telegrams if required. And if then after ordering cost, you have ordered this much quantity of raw materials, let's say through tenders or whatever, then you need space. When it has come back, immediately you won't using all the time, within 24 hours you won't be using all the raw materials for your production process. You need some space to store your raw material, so this also kills your cost. Then again, a person has to see whether check before ordering, he has to go to that place and he has to check whether the raw materials that you have that he's going to purchase it of good quality or not. So that includes your traveling cost. So the all these cost comes under your ordering cost. Fine. Next is your purchase cost. So now comes your purchase price. Purchase price is what? The ordering cost. See the difference between ordering cost and purchase cost. You're ordering the raw material. You're purchasing the raw materials. But purchase cost means you're purchasing the some sub part from other companies that you are not producing in your company. Suppose out of 20 parts you are producing 15 components, five sub components you are purchasing from some other supplier. That is your purchase cost P. Okay.
Like Apple iPhone.
Yes. Okay. Most of the things nowadays, even Maruti used to do the same thing, isn't it? They used to assemble it, they used to procure parts or subparts from other companies. So likewise, whatever they used to calculate everything else, everything else, then they used to set up their selling price so that this much profit they are earning it. So that is a purchase cost. Fine. Next, fourth one is your carrying or holding cost. The carrying cost is carrying and holding cost is means you're holding the inventory. That means it includes your rent for your space for storage. And suppose whatever carrying cost means, suppose that inventory that means you have ordered is, suppose let's say it is 2 lakhs. So you are 2 lakhs rupees you are blocking in your inventory items. Okay. So if you would have invested in some financial institutions like banks or somewhere else, you would have earned some interest on that. So that is also a carrying cost, that you are not getting it. And even you have to pay the insurance money also. Whatever the items you have stored in your inventory, the people used to insure it. Suppose there is a fire hazard. So what will happen? There will be huge loss. So insurance, you have to do the insurance. You have to pay money to the insurance company. That includes your carrying cost. Okay, then taxes, then so many other things, furniture and everything else you require it. And even you have to pay the person who is taking care of your inventory goods. So these things includes your carrying or holding cost. Then shortage cost, from the name itself, it shows that you don't have any material. Suppose you want need subpart for the final product, but you don't have right now, so you have to wait. So that is the penalty cost or the shortage cost. You don't have, you're running out of that stock, so it is a loss of the potential profit. Okay. So and sometimes that is the thing. And even you customer see your main importance for a firm is are the customers. And if you cannot if customer demands, suppose let's say 50 items of any product, but due to some problem you cannot deliver 50 products, you are delivering 40 products, so you're losing a goodwill of the customer. So that all these things comes under your stock out or the shortage cost. And last one is your revenue cost. Revenue cost is that when the when the price and the demand of a product are not under the control of organization. So sometimes what happens that revenue from the sales is independent of company's inventory policy. So it's not always possible. So that comes under your revenue cost. Okay. So I think this terms you're clear, different cost clear. Okay, in the next class again I will recap all this cost and we'll work out for different models, inventory control models. Okay, and different factors in affecting the inventory control. That is very important. Different factors. Okay, you should. These are the different costs you have known today, and again there are different factors also which also controls the inventory, and inventory control is very much important. Okay, okay, then I'm stopping here. Rules or not. In this case, maximum time, minimum timing of machine 1, minimum timing of machine 1 is your 6. Okay, so it is 6. It should be it should be greater than or equal to maximum timing of machine 2. What is the maximum time of machine 2? In this case it is your 6. So as this 6 is equal to this 6, so it is fulfilling one of the criteria. And what is the second condition? Second condition is similarly minimum of machine 3 timing. Minimum of machine 3 timing is your 4. 4 should be less than or equal to, it should be 6, but it is not obeying it, but as one of the it is the condition, or minimum of this condition, as this condition is satisfying, so it doesn't matter whether the second condition is obeying or not. So we can use Johnson's rule. Followed?
Yes, sir.
Okay. So next step, second step is that the first condition we have done, we have checked whether we can use Johnson's rule or not. Second, we have to add it up. We have to add the timings of machine 1 plus machine 2. So machine 1 plus machine 2, now this timing 8 plus 5, it is 13. Now I am giving this name machine A. Timing I am giving as machine A. Similarly, machine B, it is the timing of machine 2 plus machine 3. So 5 plus 4, 9. Likewise, if you add it up, you will get this sort of timing. Now comes the optimal sequence. Now it is converted into a single two machine Johnson's rule problem. So it seems to be very easy now. Now we can do it. First of all, the minimum timing out of these two columns is your 8. Okay, and this 8 belongs to your machine number 3. So we can now cut this. No, now we can cut this, and this 8 belongs to machine 3. As it belongs to machine A, we will start filling the machine from left hand side. So we have written 3. Okay, so we have written 3. Okay, next you can see the confusion. Next most the smallest timing is your 9. 9, you can see 9, you're having 3 nines, isn't it? 3 nines for job number 1, for job number 4, and job number 5. So here there was a confusion among students. Which one to consider? You can see that all these 3 nines you are having 3 timings, 13, 10 and 15. You have to choose the smallest one. Smallest one belongs, that means it is your 10. 9 with corresponding to your 9 time, it is the 10 is the smallest one, and it corresponds to your job number 4. As it belongs to machine B, so you will start filling from the extreme right hand side. So now I will write down 4 here. Okay, okay. Then now I will cut this one. Next, out of these two nines of job number 1 and job number 5, again, if we follow this rule, then it goes to the job number 1. We will cut this one, job number 1, and we will fill job number 1 from the right hand side because this 9 belongs to machine B. Okay. Now the remaining one is your 9 1 is your job number 5. We will cut this one, and so now it is your job number 5. The last one that is remaining is your job number 2. So in this way you got the optimal sequence. So now I will let you explain. So other sequence, if you don't follow that rule of minimum time in case of identical timings of any of the machines, then other sequences that you will be getting it, your 3 is fixed, it may be 5415, it may be 451, isn't it? So suppose other two sequences are these two. Now I will by why this rule we are following it, minimum time, that I'll work out by means of your idle time on machines. Okay, so now we will start filling. I think you can very well do it. Idle times on machines. Can't you do it? Can't you do it? I have taught you in the previous class, right? So idle time on
Sure.
machines. Okay, work out with me. Idle times on machine 2 and again idle time on machine 3. Okay. So these things you already know. I'm not discussing it. I'm just filling it. I'll let you know. So in this way, we have filled all the columns of in time, out time for all the three machines. Now idle time for machine 2 is your 6. You can see because it has to wait. It has to wait up to 6 minutes. So it is your 6. And again the idle time for machine 3. It is your 8 minutes. It has to wait for 8 minutes. So it is your 6 and 8. Similarly, in the second case, it is your, you can see that idle time for machine 2 is, it has to wait for another 8 minutes. So it is your 8, it is your 8, it is your 6. Here in this case, it is your 5, 0, 4. Now it is your 4, 4. It is your 2. Class I have already told you. Now what you do, you add it up the idle times. Idle times is desirable or it is not desirable? Tell me.
Undesirable.
Non-desirable because it is a wastage of your machines, isn't it? So now add the idle time of machine 2 as well as the idle time of machine 3 of this sequence. This is the job sequence of your optimal job sequence of your 3 2 5 1 4. Okay, now if you add it up, what is the total idle time of machine 2? Tell me. Total and tell me. Come on, tell me what is the total time. Add it up quickly.
25 minutes.
25. Okay, in what is the idle time of machine 3?
19.
19. Okay, fine. Now the same thing you do for other two sequences 3 to 4 1 5. Okay, so for this sequence we got it, and other sequence is your 3 to 4.
19.
Which one is 19? This is your 19. Okay, have you calculated the idle time for other two sequences? Anybody? Okay, you work out. Okay, similarly, if you go for, so I am calculating the idle times of machine 2 and 3 by other two sequences. This is your job. Sequence is suppose 3, 2, 4, 1, and 5. Okay. Then this is your machine 1. Let's say machine 1 in or out time, machine 2 in or out time. These students you can work out by yourself. So it will be a practice for you right now in the class. Okay. And I will be very happy
Oh,
for.
excuse me, ma'am.
Yes, tell me.
Ma'am, in exam, do we need to work out each and every possibility or any
No,
possibility that
no.
we
I
take?
told you na. Just now I've told you no need to work out the other possibilities. I told you why this is the see you are getting three sequences in this problem, right? But in this sequence, but I am considering 32514 is your optimal sequence because you are considering the minimum time of all the equal timings of machines. See, you are getting in the three cases. This was a minimum. I explained you just now. Okay, but
Yes,
I'm
ma'am.
showing you all these things. So you should know why I am considering the minimum time. What is the reason behind it? Okay, this is for your explanation only, and it will be a practice for you just now how to calculate the in out times and idle times for machines. Fine.
Yes, ma'am.
Okay. Then this is the idle time on. Let's say it is